When doing equivalent fractions, there's a couple different ways that you can come up with several equivalent fractions for a fraction that is given. So in this case, we're going to use the area model to help us come up with equivalent fractions. So this fraction here is 1/4 because there's one piece shaded and there's 4 pieces total. So fractions are all about being equal. So when we come up with equivalent fractions, we're trying to find a fraction that equals the same value but is represented by a different fraction. So I'm going to take my fraction picture and I'm going to divide each piece into smaller pieces. And whatever I do to one piece, I have to do to every piece because we're trying to make it equal. So in this case, I'm going to take my 1/4 and I'm going to divide a piece in half. So now my one piece is 2 pieces. But because I did it to one piece, I have to make sure I go and do it to every piece in the figure. So now I didn't change any shading. Nothing more is shaded and nothing less is shaded, but I just turned my shape into more pieces. So while the value is still 1/4, now there are 2 pieces shaded out of 8 pieces total. So I know that 1/4 equals 2/8. I could also do the same thing over here. Maybe I don't want to just divide this shape into 2 pieces. Maybe I want to take this and I'm going to divide my shape, each section now into 3 pieces. So where I had 1/3, now each piece is being divided into 3 pieces. So now nothing more is shaded, nothing has changed except I chunked my shape into smaller pieces. So now there are 3 pieces shaded and 9 pieces total. Over here we could do the same thing. There's 3 shaded and there's 4 pieces total. So I'm going to take each one of these and I'm going to divide it into 4 pieces. So each of my 1 pieces is now being turned into 4 pieces. So now I have 4, 8, 10, 12, and there are 16 total. So 3/4 has the same value as 12/16. Another way to do this would be to use the identity property. And that is where we multiply by 1 to get the same value. So we talked in class about how 1 doesn't always have to be just 1. We know we're working with fractions, and if we have all of the pieces out of a shape, say if we had 2 halves, that equals 1. Or if we had 3/3, that equals 1. So we're going to take that idea and we're going to use it to show how this works. So we've got, sorry, with the lights. So we have 1/4 over here. Now, in 1/4 up here, we turned each of our pieces into 2 pieces. So that means we're going to multiply by 2 halves because we're turning each of our fourths, we're making it into 2 pieces. So when we multiply our fractions across, we just multiply numerators together, which makes it 2, and then we multiply our denominators together. 4 times 2 is 8. So this is the identity property because this number is equal to 1. So it's the same value on the other side, it's just a different fractal representation. Over here we have 1/3. We took each of our pieces and divided it into 3 pieces, so we're going to multiply by 3/3, which gives us 3/9. And once again, this is equal to 1 using our identity property. And our last one, we have 3/4. We put each of our pieces into 4 pieces, so we multiply by 4/4, and that gives us 12/16.